Hi everyone, welcome to our webinar today. This webinar is a presentation of Clean Energy Group's Resilient Power Project, and our topic for this webinar is what are flow batteries and how can they improve resiliency, continuity, and safety in urban installations. And our host for this webinar will be Seth Mullendor. Seth is a project manager at Clean Energy Group. And before I pass it over to Seth, I'd like to go over a few quick housekeeping notes. All of our participants for this webinar are in listen-only mode. This means that you can hopefully hear us, but we can't hear you. You have a couple of options for joining the audio portion of this webinar. You can call in using your telephone, or you can listen in using your computer mic and speakers. A very important note, we ask that all of our attendees please submit your questions as you think of them throughout the webinar by typing them into the question box on your webinar console and hitting send. And we will be reading through your questions as they come in, and we will leave some time at the end for Q&A following our presentations. We'll get to as many questions as time allows, so get your question in as you think of it. Don't wait till the end to put that in. And finally, this webinar is being recorded. You will find a recording of this webinar as well as webinar slides, along with all of our previous webinars on our website at resilient-power.org. And with that, I'll pass it over to our host for this webinar, Seth Mullendor.
Great, thank you, Sam. Thanks everybody for joining us today for the webinar. I just want to give you a little bit of background about who we are at Clean Energy Group. So Clean Energy Group is a national nonprofit working for the advancement of clean energy technologies through innovation, finance, and policy. We also have a sister organization called the Clean Energy States Alliance that is a membership organization of state energy fund managers. And this webinar today is brought to you by the Resilient Power Project. Resilient Power Project is a collaboration between Clean Energy Group and Meridian Institute and has the generous funding of a number of foundations, JPB Foundation, Kresge, CERDNA, Cummings Foundation, and Barr Foundation. The Resilient Power Project has been around for a couple of years now, and the project is designed to increase public and private investment in clean, resilient power systems. These are systems that can work independent of the grid and are much cleaner and more reliable than, say, diesel generators. In this project, we engage with city officials as well as state and federal policymakers and officials to help develop resilient power policies and programs and to get resilient power projects developed in communities across the country. In particular, we have an interest in protecting low-income and other vulnerable communities such as seniors and the like. And we have a big focus on affordable housing and the critical public facilities that support them, so getting projects done in those types of facilities. In addition to advocating for policies and programs, we also have a small technical assistance fund that can go towards projects, resilient power projects, for the pre-development costs to help determine the technical and financial feasibility of those projects and get them going, so we step in that respect, early phase in the project. We've done a lot of reporting on this. We have newsletters and, of course, webinars like this that we put out regularly on our website. So it's resilient-power.org. Urge you to go there and check things out. This webinar will be on there shortly, as well as a lot of the work that we've done over the years. So there's quite a bit of information if you want to learn more about resilient power and the work that we've been doing, as well as projects that are either in development or have already been deployed across the country. With that, I'd like to introduce today's speakers. We have with us a couple of experts on flow batteries and how they can be used for resiliency and the different aspects of those systems. So we have Mark Johnson, who is the Smart Cities Chief at Schneider Electric. Previously, Mark has worked for the U.S. Department of Energy, Navigant Consulting, IBM Energy, and several energy startups. Mark has a BA from the University of Notre Dame and an MBA from Loyola College. We also have Mike Grinnell with us. He is Vice President of Marketing at Vision Energy Systems. Mike has more than 15 years of experience working in clean energy technologies. Previously, he's worked in executive marketing and sales leadership roles for Trina Solar, which he helped them grow into the world's largest solar panel manufacturer. And prior to that, he served as a product line manager for General Electric's wind energy business, which grew 10 times while he was there. Mark has a Bachelor's of Science in Mechanical Engineering from Washington University in St. Louis and received his MBA in Finance from Columbia University. So with that, I'd like to turn things over to Mark and Mike. And as Sam said, please do submit your questions as you think of them.
Thank you so much, Seth. This is Mark Johnson, since everybody doesn't know my voice. and Mike, if you don't mind, I'll do the first couple of slides and then turn it over to you, okay?
Absolutely.
Okay, good. Sam, why don't we go to the next slide, please? And many people wonder, how, we got involved, we being Schneider Electric got involved with flow batteries. And the shout out and credit goes to Grid Market in New York, which we all know does a good job helping people understand the maze of opportunities. And we're doing work in New York City, which is, it's well known that the fire department prohibits lithium ion. So that's how we found flow batteries. It's not that I had a brilliant flash one day. It's actually, I was told this was the best solution. So it's kind of funny how things happen. But as we all know from our work, energy storage opportunities are literally everywhere. I mean, one of my favorite analogies for the opportunities is if you vision energy storage as kind of a quilt, a patchwork of storage. We look at them as microgrids, in fact, across the United States, ideally behind the meter or behind the substation, on the customer side of the substation, and typically campus environments, correctional facilities, areas where you have large megawatt loads and above that can use trading and settlement and ISO programs and utility programs to pay for the assets, being the batteries, the inverters, and the engineering and the controls to put everything together. But this is a good slide of really what we focus on for helping people create resiliency in a urban environment. And again, really you could simplify this in two words. One is load, megawatt and above, and the other is space, because as we'll learn, batteries do take up, they're hogs, right? They're space hogs. So they do take up space, and that's a requirement for the successful deployment of battery storage and then battery storage microgrid situations. Sam, can we go to the next slide, please? Hello, Sam. Thank you. Oh, this is Mike. Mike, take it away. Thank you.
Thanks a lot, Mark, and thank you very much, Seth and Sam, for that excellent introduction and this opportunity to talk about flow batteries. Vision is a flow battery manufacturer, and we have been in operations for 8 years. We picked up technology that was being worked on by the U.S. Department of Energy for 8 years prior to the foundation of our company. What is a flow battery? I'm sure just about most people on the phone have seen, if they've been to Wikipedia, have seen this image on the upper left. And what it shows is 2 large tanks of fluid with a cell in the middle, and those tanks circulate throughout the cell, and the fluids are consistently separated by a membrane across which electrons and charged particles can flow to create current and voltage. Okay, that's good from a science perspective, but what does it look like in real life? The image just below is an isometric view of the Vision system. The big orange blocks on the bottom inside this 20-foot shipping container are tanks. They're rotomolded tanks. Imagine, a kayak, a sea kayak, that same thickness, similar material, but made 20 feet long and big enough to fit, almost 1,000 to 1,900 gallons of the either the electrolyte fluid, which is called the analyte on one side, and the catholyte on the other. Those blue cylindrical structures that you see are pumps, and those tubes are plumbing. And that material flows, the analyte and the catholyte flows to, in this situation, 5 separate stacks of cells. Each one of those stacks of cells is about 20 kilowatts. You put 5 of them in series and you get to 100 kilowatts. And that's our product. It's available in 20-foot shipping containers. It's available in 40-foot shipping containers stacked on top of each other. It can be anywhere from 60 kilowatts to 240 kilowatts. You can line them up to create megawatts and hundreds of megawatts. All of our products are made here in the USA. Just recently, just about a year ago, we transitioned all manufacturing to Jabil, the 3rd largest contract manufacturer in the world. They're ISO 9001 certified, and we've been in active commercial deliveries since then. Next slide, please. Thank you. So energy storage, as you've probably heard in webinar after webinar after webinar, is unique in the manner in which it creates value. We're not going to spend too much time talking about stacked revenue services or multi-use battery systems, but I think everybody will agree that energy storage creates more and more value the closer it gets towards the edge of the grid, the closer it gets towards actual facilities that use energy, the closer it gets to the meter and the actual operational environment. And so when we talk to people and we ask them, what are you going to use their batteries for? They say, well, we might use them for energy storage to provide resiliency today. They might also service this ancillary market. We might use them for peaking, but we don't know what we're going to use them for in 15, 20 years. And so I think it's important that when folks are looking at different energy storage technologies, they start asking themselves, well, how do I plan to have not just today's services, but how do I make sure I'm ready for the future, for years 10 through 15 and 15 through 20? The other critical aspect is siting, permitting, and insurance, right? So actually getting these batteries placed, getting a series of third parties to approve them and permitting is critical. Lastly, over the course of their life, what am I going to have to do to them to keep them running at 100%? What does the operations and maintenance cycle look like? All these things are critical aspects of selecting the right energy storage system. Next slide. So what is inside a Vision Flow battery? So if you look to the right side of the slide, you see those pallets with big stacks of white powder. So our batteries ship to the exact site where they will be located, and they ship dry, meaning they ship without electrolyte inside them. They are de-energized, and that's really important when you start talking to contractors who have to move them around on the sites before the analyte and the catholyte are loaded in. So then what do? Then we take some local tap water. We will usually soften that water. We load thousands of gallons of it into the tanks. Before we do that, on the analyte side, we mix it with zinc oxide, which comes in a powdered form. We can buy it locally. It's basically the exact same chemical compound that you're going to be rubbing on your face next week on spring break in suntan lotion. In the catholyte, we mix in what's called yellow prussiate of soda. It's basically an anti-caking agent. And when you're on spring break next week, you look at your salt shaker, you'll see that it's used as an anti-caking agent, and you eat the stuff all the time. So tap water, zinc oxide powder, yellow prussiate of soda, and then some alkaline solution of KOH and NaOH. Go into the mix. We have a proprietary blender. It all gets loaded up. It's being loaded up by people in long rubber gloves and safety goggles. They are not in bunny suits, right? This is not hazmat stuff. This is basic plumbing. So that's what's inside. Next slide, please. So and Mark, I'll do the left side of this, and you can do the right. But the question and the topic of today's webinar is safety. Okay, so we have a alkaline solution inside a shipping container. What could go wrong? And I want to just explain briefly the safety net that we have built around our chemistry. So first and foremost, these things ship dry and de-energized, which is really important for the reasons I stated on the previous slide. We've also talked about the safe chemistry and the fact that there are no flammable electrolytes. There's been an argument made that these electrolytes are inside the seamless tanks. The seamless tanks are, almost a 1/4 inch thick. They're really, really thick and robust. Then you have those seamless tanks, and around those seamless tanks you have a diaphragm, which is also built into the container. Outside the diaphragm, you have a sealed container. So now you have 3 different layers. Throughout these layers, there are leak detection sensors that are wired to the main controller that's monitored 24/7. If anything should ever go wrong, you can either locally or remotely automatically hit the emergency off button. As you saw earlier in the isometric depiction of the system, the electrolytes are up inside the stacks creating voltage and current. When you hit this emergency off button, it automatically drains the system in 15 seconds. And so, these systems will be connected to the building's infrastructure using bus bars, using big, thick wires. Within 10 to 15 seconds of this being de-energized, a fireman could come up and he could hang a crowbar on that bus bar and there would be no voltage and no current, okay? So, God forbid, any of that current or voltage should ever kind of overheat a fuse or blow a fuse or want to short out a wire inside the container as a last resort. If we're ever to create any smoke, there's built-in fire suppression that's both automatic and can be tied into the building's safety systems as well. Mark, do you want to talk about the controller and event management?
Yeah, no, thank you, Mike. Appreciate it. And, to pick up on Mike's point about safety and redundancy and certainly protection, at Schneider Electric, we have 3 big values for an energy storage system. And again, as I mentioned earlier, we look at these systems as microgrids, quite frankly. One is, of course, the obvious of our inverter, but more importantly for everybody on this call, there's the controls. And the controls connect, obviously, with the battery. You could see the icon there in the center of the slide there where it says microgrid controller. Right below it, there's a battery-looking icon. But it also connects to all the other distributed energy resources. And, of course, because everybody loves three-letter acronyms, they're DIR boxes, aren't they? So that's what a DIR is, like a distributed energy resource. Wind turbines, solar, batteries, that kind of thing. And that's how we set up the architecture and the controls so that there's, redundant systems for safety. That's the purpose. On top of those DIR boxes, and each distributed energy system has their own independent DIR box with, as you can see in the schematic, the microgrid controller. You have a macro system controller. We call it demand side operation, but that's the connectivity and the backbone, the architecture that we call structureware. So not to confuse you, but that's the enablement for on off, which one's optimized, and we can go into greater detail if you guys have seen that both Mike's email and my email are on the front and last page of the PowerPoint, but and so feel free to reach out to us and we can give you more details on these things. But the demand side operation software is regulating and optimizing and maximizing the use of the battery for, as Mike mentioned earlier in the presentation, what are you doing? Peak shaving? Are you doing settlement services? Are you doing frequency regulation, demand response, whatever you're doing. And it helps the settlement traders the curtailment service providers to optimize those specific assets. So the point of the demand-side operation is controlling those assets with controls that are utility grade and certainly robust systems that obviously Schneider Electric guarantees and warranties, and that's what you need. You need that kind of connectivity. You need that kind of robustness to operate a serious system. So that's what this schematic is. And there's too much more that we do, and we'd be glad to do that, but this is a good overview for your benefit. You can see the connectivity in the upper right-hand corner, obviously to the grid. Certainly we pull in weather because we own a weather service company, Weather Century, and then whatever constraints the customers have with their buildings or loads, and of course the market. The trading, the settlement, the arbitrage that a customer and their service provider would want to do. So that's that slide. Next slide, please, Sam.
So it's always important to think about not just how much money could I save or what's the payback, but what could happen if something went wrong. We use things like natural disasters or nearby explosions. Some of my better salespeople talk about 747s coming out of the sky and smashing into these things, or if there was a fire. And so, it's really important to think these things through because it impacts not just siting and permitting, but also your facility insurance. And so, if you look at the vision system, the concept of a all-out leak could be easily neutralized with common materials that you could have on site and be ready. Easy to dispose of via local guidelines. There are a lot of companies that do willing to come and just vacuum this stuff up. It has the same sort of chemical signature as Purell, if you've ever used that to essentially wash your hands. In some jurisdictions, it's even sewerable, meaning you could wash it down the drain. Next slide, please. So we recently did a project with an installation at Randolph Macon College in Georgia. And the college was looking for a way to just deploy in a microgrid format solar and energy storage on top of their administrative building. They wanted to have the capability during outages to preserve their critical infrastructure and ensure that there were portions of their overall campus that were still electrified. And so after exhausting and going on a broad search, they found Vision Systems. We brought together the parties that were needed to execute and deploy this system into their facility with a 20-year life at roughly 120% of the critical power needs for that facility. And not only did we give them the resiliency, but they also gave them the ability to get the entire campus easily back online when the grid power came back on again. I'm going to hand it over to Mark on the next slide because he's going to talk a little bit about the Schneider solution and some of the financial options that are available to building owners and users.
Thanks, Mike. Yeah, to help everybody through this process, because it is complex, but we try to simplify it as much as possible, is obviously we want to involve our electrical engineers who we consider to be the most valuable players, certainly on our team. And we want to be able to partner and identify and team with all of the input sources. And so many situations they may have CHP or diesel gensets or natural gas, whatever, fuel cells or something, whatever those the local generation source might be. But they also may have solar right? They might have solar that they want to tap into and utilize because they didn't think of storage previously. And storage historically, as we all know, was really lead acid battery in your car, and then just recently graduated to lithium ion, which are excellent opportunities and excellent choices for the right application. And then now we have flow batteries, which is a nice third option to have as well. So what we do to help people navigate through this kind of, complex situation with a lot of different exigencies is to offer a no-cost financial analysis. And we've done this with a lot of different entities, grid market, of course, vision, of course, but also most importantly with the financial people that provide the options for your financing of these these energy storage systems. And there's actually 6 options. I put down 5. One of the options is do nothing, but you can buy it outright with cash, of course, but not a lot of people have an energy storage microgrid on their budget. That's so coming up with a $3 or $4 million, and that's typical for a megawatt size system, is tough to come up with. So there is leases available from third-party sources. There are PPAs available, and both of those, as you can imagine, are graduates of the solar industry that was successfully built on PPAs and leases. We also have worked with people on shared savings, and when I say shared savings, as you know, a lot of the systems are paid for by the arbitrage with the ISO, whether it's PJM or the New England ISO, certainly California ISO, New York ISO, or the utilities as well. They have a lot of programs and incentives in all of these areas, most notably in New York, California, and Chicago for energy storage systems. And so shared savings are typical financing methods that we do or we have done with customers where they share in the upside potential of the arbitrage, and that works well too. Another one is where the entity is either a government or a 501c3, and they're not so interested in upside, and they just want a flat land lease, kind of like a cell phone tower. If you ever noticed how the cell phone towers got up to, I think their current census is about 250,000 cell phone towers across the United States, which I predict that you'll see that many megawatt battery energy storage microgrids across the United States to the tune of 250,000 as well. But those are, the cell phone tower program is on a land lease payment. So every month they pay, $4,000 or $5,000 a month for the privilege of having the cell phone tower there. And that's a fixed fee payment that the host, again, enjoys without risk or upside or out-of-pocket or, that type of thing. So there's different options that you can choose from. We work with, we're agnostic. And we're agnostic on the battery as well as our financing partners. And so we'll help shepherd through that. But at the end of the day, you do need electrical engineers to vet and verify all of the inputs, all of the costs, so that it becomes almost like an investment grade audit that you can provide to the financing people so that you get the lowest cost. And we've seen that happen where the costs for lease or PPA in fact goes down because we vetted the numbers and the inputs were the costs were reduced or the revenues were increased. So there's a lot of moving parts, but it's not as complex or complicated as you think. The financial analysis are built upon generally accepted practices. Most of the approach is, as I mentioned, a growth of the very successful solar industry. Use many of the same tools, for that, including Homer. If you're familiar with Homer, That's included, obviously, for people with solar. And, of course, as you know, a couple of months ago, Congress passed the ITC for solar. So the investment tax credit can be extended to energy storage within the rules. Of course, there's many rules that you have to pay attention to, but we'll help through that process. So thank you, Sam. Could you advance to the next slide, please? This is just kind of people want to know what Schneider Electric has done for microgrids and engineering and inverters. As you remember, we bought the company called Xantrex. We call the inverters for the megawatt scale connects, and it's all on the website. But Schneider Electric is, as you can imagine, owns Square D and APC and Telvent and Summit Energy and Pelco. So there's just a lot of collection of resources, both with electrical engineers, as I mentioned, our MVPs, but controls, a lot of low voltage, medium voltage, and high voltage controls, hardware, firmware, software. I'm proud to say that Vision, in fact, has gone through our exhaustive connectivity and firmware integration. And our inverters are headquartered up in Burnaby, Canada. So they've gone through that exhaustive process for the various implementations that we're working on with them around the world. And so that's a nice, tough hurdle to overcome, but they've successfully done it. And again, I think the biggest part of the trust from Schneider Electric is that they will make things work. You know, at the end of the day, they have the rigor for the grid quality, and they certainly are going to stand behind, guarantee, warranty everything they touch. Next slide, please. The picture on the right is kind of a helpful overview. Now that I look at it, it doesn't look that helpful, but it's supposed to be a helpful, simplistic overview of where energy storage and microgrids can go within your operation. I think for the simplicity of the listeners on the phone call, think of if you have a megawatt load, which you most likely have if you're a campus. Think of a location closest to your substation with space for 40-foot containers, and 40-foot containers are 40 by 10 by 10, FYI. And all we need to do an analysis to see if it pencils is, as I said, just 12 months of your interval data, your 15-minute interval data in kilowatts, in kilowatt hours, and with your tariff, and we'll be able to provide you with a no-cost financial analysis to see if it works. And that's a very simple way to go. It certainly is something that you can play with and edit and audit. And the first step, as I mentioned before, is an engineering study just to vet and verify the numbers that you agree with. So I think that kind of transparency, knowledge sharing, and disclosure is helpful to everybody because, let's face it, this is all new. It's new for everybody on this phone call, and certainly we think, we all believe, or we wouldn't be on this phone call, that it's going to be a high-growth area that we want to help with best practices. So thank you very much. That's all I have. Mike, do you have any closing comments?
No, I just, again, want to thank everybody. I'm looking forward to the Q&A. Mark, Seth, Sam, this has been a great beginning of a discussion, and looking forward to talking some more.
Great. Thank you, Mark and Mike. It's good. We've got a lot of time here for questions, which is great because we have a surprising amount of questions. They're kind of all over the board, so I'm just going to get right to them and try to get them answered as they came in. I think we might have time to get to all of them, so let's get started. Mike, you mentioned in a diagram that you showed it was a 100 kilowatt capacity. What would the kilowatt hour rating for a battery of that size be?
Sure, sure. So the majority of our systems that we're shipping today are all rated at 3 hours. So if it's 100 kilowatt, it's a 300 kilowatt hour battery. Now, come January, February of 2017, the nice thing about flow batteries, if you want to go from kilowatt hour rating X to kilowatt hour rating 2X, all you need to do is take what we call the energy module, but what you saw at the tanks, and double their size. And so you can use the same nominal stack design, the same power generator, the same engine, and just pump more fluid through it. And so next year, we're going to be moving to a 4-hour battery system. And, you know, we're actively quoting those systems now for delivery in mid-2017.
Great. So with that longer duration, that's longer usually than lithium-ion batteries are rated for, are your flow batteries more ideally designed for things like resiliency or capacity as opposed to, say, frequency regulation, which is a much shorter time span?
Sure, sure. So we're a pretty unique flow battery in such that we can deliver both frequency response and voltage support for the grid in the high power regime, as well as deliver the long duration energy services, I would say simultaneously, but what I mean with is that they can be done and scheduled throughout the day. Our battery can cycle 2 times a day, and whether it's at 90% state of charge or 10% state of charge, we're able to stop what we're doing on the energy side and deliver those ISO services, you know, in PJM territory or in California.
Great. So that's a full cycle twice a day?
Right, right.
Great. So what about long-term storage of energy? Does the electrolyte hold a charge for long periods, say over a day, you know, or even longer?
Sure, sure. So the charge loss is negligible. And so what we see is up to 48 hours, the charge loss is negligible and the performance of the battery is strong. And, you know, you just need to maintain the electrolyte at a pretty normal temperature. And in a lot of environments, you don't even need to operate the pumps or the heaters to keep it warm because, you know, the energy that's moving around inside the battery with the friction of the fluid in the stacks is enough to keep it warm.
Okay, switching gears a little, market question. Over the 8 years that the Vision batteries have been sold commercially, what kind of market growth have you seen? Can you give us any sort of metrics on that?
For the battery storage market, is that the question, Seth?
Well, I think more specifically for flow batteries or for you know, Vision's batteries in particular.
Oh, right. Well, that's an easy one. The Vision wasn't invented, right, you know, before that, so before that period of time. So the commercialization of flow batteries, frankly, is just now. It's just starting. We're currently working on over a dozen projects with Vision, both in implementing Vision batteries in situations in multi-megawatt use applications, as well as doing the preliminary engineering. So it's all new, it's all straight up in the air, and it's, you know, all hockey stick right now.
Yeah, so have there been any full deployments yet, or is they all projects that are currently in development?
For Schneider Electric, we have not completed and commissioned a final flow battery Vision installation. We have several in process that should be done this year. And the Randolph Macon College, which is fully operational flow battery by Vision, was done by Dominion and not by Schneider Electric. So, but that's operative, and that was commissioned, I think, late last year, wasn't it, Mike?
Yeah, there are 4 commercial systems that have been deployed, and by the end of this year, we expect to have shipped over 100 megawatt hours worth of Vision systems globally. And that includes wind and microgrids and behind the meter and in front of the meter utility scale systems in Europe.
That's great. It's fantastic. So back to some of the mechanics. Specific question on the containment. What kind of containment is needed for the alkaline in the battery?
Sure. So all the containment that you would need is integrated within the structure, right? You know, most flow batteries have an acidic chemistry, and that acid tends to require very specialized materials within the pumps and within the tubing and within the tanks. The fact that we're alkaline means that we're not essentially eating our own hardware from the inside. And so all of our hardware, all of our pumps, all of our tanks, it's all rated for 20 years of life. And, you know, the O&M on these things is the moral equivalent of checking the pH in your swimming pool and adding some more chlorine on an annual basis.
Right, so that's 20 years with the two cycling twice daily. Is that the 20-year lifespan?
Yeah, this battery enjoys being used, right? And what that means is it likes to go from 100% state of charge all the way down to 0 and beyond twice a day to maintain essentially, you know, its ideal performance level. And, you know, so it can be used within that range. It can be used a lot less, but in an ideal application, it's energy intense. And while it's doing that those energy intense services, it can also pause and provide frequency regulation and voltage and bar support.
So you're saying it can be fully discharged? There's no depth of discharge limitation then?
No, as a matter of fact, every couple weeks, if you see any degradation in battery performance, what we actually ask the user to do, and this typically happens during normal use anyway, is actually run it all the way down to 0, 100% depth of discharge, and then you get all the capacity back.
So that flows into another question of what is degradation like for flow battery systems. Maybe you can talk about that a bit more.
Sure. So provided the systems are operated and maintained properly, and you know they are monitored 24/7, and you know per our operations and maintenance manual, the owner does everything we ask them to do. It's our expectation that these batteries have a 20-year life with negligible degradation in performance and 2 cycles a day.
So what is the 20-year limitation? If it's not degrading, if there's no degradation over time, what is the cutoff for the 20 years? Is that mechanical?
You know, that's a great question. And, you know, as Mark said, we've been shipping these batteries for 18 to 24 months. And, you know, we feel really great about being able to talk about the 20-year life of our product, and we tested that through accelerated life testing. And we think that's 2x or 3x what you're going to get from competitive industry-leading battery suppliers. We also like to talk to bankers about residual life because these systems, there's a lot of residual value. And at end of life, let's say the PPA is over or the lease is over, it's just like solar. I mean, there's a credible argument for a banker to say that I'm going to put in here a terminal value of somewhere north of 0, somewhere less than 100% of the system. And, you know, let's say they want to replace the stacks or they want to retire it to the energy storage boneyard out there on the grid somewhere. There's value. And exactly what that's going to be, I don't know.
Okay, interesting. So over the life of the battery, what type of maintenance is needed to maintain the electrolyte system?
So like I said earlier, the programmed maintenance on this system is primarily going out and checking the chemistry of the electrolyte. Pardon me. I think I swallowed a fly. Pardon me. Oh, sorry. And so what you're doing is checking the pH or the equivalent of, and then leveling it off. We do not expect at any point in time during the life of the system for the chemistry to need to be drained, removed, or replaced. Like we said, if that needs to happen, then it's something that can be done easily and you don't require bunny suits and hazmat teams to do so. And if you talk about O&M and you look at what's likely to break on these things, when we run our financial model, right, which Mark talked about in depth, right, it has a very big chunk of it that's dedicated to operations and maintenance. And what you see in there is that we typically plan for our pumps to fail. We plan for them to fail not once, but conservatively twice during the life of the product. So it's critical, to know that the pumps will likely fail, they'll likely burn out, and that our cash flow models are conservative as far as O&M is concerned, and that they're easily replaceable using, local tools you can find anywhere. And, the other key concept is anybody who's ever studied solar or wind or energy for that matter, when they look at the cost to own something, look at first cost, and they look at the net present value of operations and maintenance, including new parts they need to buy, okay? And what we see is that amount, that net present value of operations and maintenance and parts you need to buy, is a small fraction of what it is for lithium-ion, where at least once during 20 years, you're replacing every single lithium-ion cell and module.
Yeah, that makes sense. That's very interesting. And watch out for flies over there. I hope you're doing okay. What is the operational temperature range for your flow batteries? Do they work in the heat of New Mexico and the winters of Alaska? And what does it take are they shipping containers temperature control? Do you need heat exchange? What's required to maintain the temperature?
Sure. So the containers themselves are insulated, okay? We've deployed systems in northern Montana where it gets real cold, and they run just fine. So cold isn't really the issue or the challenge. What we're really excited about is that our systems, right now we're in the middle of finalizing a deal in Kuwait, and we're finalizing a deal in the Mojave. And neither of those projects have any plan for any HVAC equipment, which means there's no massive air conditioner outside. There's so much thermal mass within our tanks, and the tanks have 3 to 4 inches of expanded polystyrene foam insulation on the inside of them, around the tanks and around the entire enclosure. There's so much thermal mass that as long as the average 24-hour temperature is within our target range, and I think the upper end of our range is like 45 or 47 degrees Celsius, y'all can download the data sheet right off our website and see that. But, let's say it gets up to in the Mojave, with the beating sun and the inside container, we've got some circulation fans going. Let's say it gets really hot during the day. As long as it gets cool at night and the average temperature is below, I think, 46 to 47 degrees C, these things run without the need for any HVAC. Now, what we might consider doing is, in addition to, in like super, super hot places, in addition to putting a high-powered fan to circulate air inside, we might consider putting a shade structure over the top of them, which is just building a simple post structure and keeping the direct irradiation off of the containers themselves. But otherwise, you don't have those auxiliary loads that you see in lithium-ion.
Okay, thanks. So we got some financial questions. One, not sure if you can answer this or it may depend on the project, but can you give us an estimate or a range of what the all-in installed costs would be for per kilowatt hour for these systems?
Boy, that's a tough one, Mike. I don't know if we can. I don't know if I would feel comfortable with that. Mike, do you have any opinion?
What I will say is it's Vision's goal, together with our partners, to deliver systems that are economically attractive and competitive, right? And what we're finding is that we're set up to do that, and each site is different, very, very different. So.
Yeah, fair enough.
I didn't mean to moonwalk on the question, Seth, but You know, the truth is I've seen, and I know everybody on this call has seen, every site is unique and different, and there's the power sources, right, for the battery to store energy. Could be the grid. They could be, as we talked about it, solar. Ideally, you know, that would be the penultimate vision for using flow batteries. But as Mike said, when we do the financial analysis and you see the inputs and the costs with the controls and the engineering and the integration and all that stuff, you know, you can move things around. And as Mike said, it either pencils immediately and you can make more efficiencies on cost and more profitability, or you know, you hit the wall and you say no. So it's more of an iterative cost, you know, collaboration and teaming. In our experience, that's been the most successful way to look at it.
Yeah, sure. You know, and I know it's a moving target trying to cost out these systems. So yeah, that's completely understandable.
One thing, though, that Mike mentioned that I think we all agree is that we're working on projects for people that want bracketed high-low pricing for not just 2017 next year, but 2018 and 19. And we're projecting cost decreases. And I think everybody agrees with that.
Yeah, that seems reasonable. I think the answer to this is yes, but are these available for leasing now?
Oh, yeah. Yeah,
Right.
and again, I think the first step is we offer a no-cost financial analysis based upon the information that I itemized, and we don't do the leasing. Schneider Electric does not do the leasing, nor does Vision, but we have third-party people that are very competitive for leasing, and you know, no offense, but we do play them off of each other, and we do competitively shop them, and it's up to the customer to decide, right? They may have their own leasing sourcing. We have other opportunities, but it's you know, again, it's just like solar was, or just like solar is, actually.
Yeah. I know, you know, one of the problems with that solar had to overcome and batteries are working on now is getting financing for these types of projects. Can you give any indication on the projects that you're working with, where the financing comes from, where the third-party financiers that are involved in these?
Yeah, no, that's a great question, Seth. The third-party financing for battery storage, you know, with or without solar, is the same guys that you worked with when you did solar. And it's you know, as you know, it's typically a small fund office with their actual source of funds is family funds and large companies that they're entrusted to do the vetting, the scrubbing, the verification of the numbers. So we use the same people that everybody's used for big solar projects. And the benefit for that is they are quite literate and quite conversant with the financial tools like Homer, right? I mean, as I mentioned earlier, we use Homer to drive a lot of the financial projections when we use solar. They're very familiar with ITC and investment tax credits. So PPAs and leases are typically the same people that you've used with solar. And I can tell you that the people that do solar, if they haven't, you know, doing storage is new, but believe me, that's their next step. Everybody in the solar business is looking and thinking and trying to come up to speed on doing storage.
And the other thing I would say, and you know, just as Mark said earlier, you know, they quote other technologies, and you know, Vision is Schneider is our number one partner. And if there are facility managers out there, I think what you're going to find is that, you know, as in these early stages, as investors start to look for solar plus storage assets to own on an equity basis, they are looking for a project wrap from a large entity who can deliver and stand behind the commitments and guarantees with their balance sheet. And that's why Schneider is such an important partner for Vision.
Great. Back to the technical side. A couple of questions. People want to know what the round trip efficiency of Vision battery is.
Sure. So round trip efficiency is an interesting number in this industry. Most battery manufacturers like to talk about it at a defined state of charge. Right? If you look at your iPhone, you look at the battery signal, you're either at 0 or 100% charge, you're in the red zone, or you're looking all green. I just warn everybody first, before I answer this question, to really read the technical spec on the batteries they're buying, because there is an efficiency curve at all states of charge in there that folks need to be aware of. And so there's also DC round-trip efficiency, DC-DC, and AC-AC. And so typically what we see in terms of DC efficiency is in the low 90%, 92 to 94% on DC-DC, and then all-in system. And this is a system that's going up and down through its paces across its entire state of charge. We come in between 72 and 74%, depending upon the system losses. And we can tighten that definition up, and throughout any process that Mark described, go ahead and give you a firm answer on that.
Okay, great. Safety question. In a remote area where there's very little access, say you can only access the region by air or difficult roads, how would you approach a safety de-energization of a battery system and cleanup if there was an issue, a failure?
Sure. So first of all of our battery systems are monitored and remotely 24/7, right? And so that de-energization can be done remotely, or it can be done with the big red button on the front of the container. The other issue that you asked about would be cleanup, right? So most of our battery systems are installed on a 6 to 12 inch thick poured concrete slab. And if you give the battery system a 3 to 4 foot walkway around it, and you put a 12-inch curb on the outside, add almost anything to the cost of the project, that's a big enough area to contain 100% of all the electrolyte if it's filled. Okay? And so it's not a ton of fluid. So, worst case scenario, you've got a little pool there. Now, what are you going to do with that in a remote area? So we're building a big project right now in a European country, and that electrolyte has been approved, and our battery's been approved for that area because it's in a floodplain in an environmentally sensitive wetlands area. And so the Ministry of Environment in Germany, which is very stringent standard for it, has looked at what it is, looked at the chemical nature of it, and approved it to be sited there.
Great, thank you.
I hope I answered your question. I think I got it up at 9 out of 10. I don't know.
I think you did. You did the spot there. Thank you. And
By the way, Seth, are we being graded? I wanted to know if we can grade Mike.
Yes, you are allowed to grade Mike. So we're pretty much out of time here. We still do have a lot of questions. There's been a lot of interest in this. So I encourage people to reach out to Mike and Mark with specific questions about flow batteries and the Schneider and Vision collaboration on microgrids. And resiliency questions you can also address to myself or others here at Clean Energy Group. I'd like to leave it with a final question. I'd like to get your thoughts just kind of generally. There have been a lot of questions about resiliency and how flow batteries and Vision flow batteries can be used in an islandable system when there is an outage. Along with solar, maybe some generation, fossil fuel generation as well. It seems like with the long kilowatt hour capacity of these batteries, the discharge time, that they're pretty well suited for resiliency applications. I'd just like to hear your thoughts on that. Maybe you can expand on what you see the role of vision batteries and flow batteries and for resiliency?
Sure.
Go ahead, Mike.
Thank you very much. Thank you very much for the question. And if folks want to hang out for a couple of minutes, we'll be happy to stick around. I have nowhere to be. The nice thing about the systems that Schneider designs, engineers, and deploys is that they know, and they have the smarts, and they have the team, and we all work together to optimize the mix of the size of the battery, the size of the solar system, the size of the generator, such that we can use a really cheap fuel like the sun, which is cheaper and cheaper and cheaper every day, and maximize it. And so, I've got a case study in progress where, we've done all the numbers on a several megawatt microgrid in an islanded situation or a tethered islanded situation. And it has that combination of diesel, solar, and storage. And what you can do is you can start to look at your sizing, and you get your smart guys to start turning the knobs and optimizing it. And you can see the diesel usage go down by 85%, and the levelized cost of electricity almost cut in half. It's really cool.
Yeah, that is cool. Actually, if you have any numbers on that or anything published, I'd really like to see that. So I know you said you can hang out, but I think people are starting to need to leave and drop off, and so I think we're gonna leave it. See Mark or Mike, if you guys have any last thoughts, and then I'll turn it back over to Sam. We'll wrap it up for today.
Thank you, Seth, and thank you, Sam. Thank you, Mike.
Thank you, everybody, for your time. Thank you, Mark. Thanks, Sam.
Yes, thank you both. This has been a great time, great webinar. So please reach out to these guys. They know all about this. So ask your questions to them directly. All right, Sam, we'll turn it over to you for some final thoughts.
Thanks, Seth. So thank you, everyone, for attending our webinar today. We will be sending you a follow-up email with a recording of the webinar as well as webinar slides, and that'll get out to you probably this afternoon. On the screen, you've got some contact info for our host for this webinar, Seth Mullendore, and some links where you can find us online. And we hope to see you soon at another webinar. Thanks, everyone.